Namaste everyone, myself Sonia, Assistant Professor in Department of Mathematics in Janki Devi Memorial College. So today we are going to discuss some topics related to real analysis which are in the first semester of the Maths Honours course, and the topics which we are going to discuss are the very well known Archimedean property. Next is density theorem, which is again a very important topic in real analysis, and then few applications related to these. In fact, density theorem is also an application of Archimedean property. We use Archimedean property and all the consequences of Archimedean property to prove this density theorem. So we will start with the Archimedean property. Okay, so to start with the Archimedean property, I am going to give you one property, which is completeness property for R. The property is the completeness property for R. Now what is that property? It says that every non-empty bounded above set must have a supremum in R. Okay. Let me just write it, non-empty bounded above set must have supremum in R. Okay, so before to study this lecture, we must know about upper bounds, lower bounds, supremum, infimum. We must have information about these things. So every non-empty bounded above set must have supremum. It seems obvious कि bounded above है, upper bound होगा, तो we can always choose a least upper bound. But we all know in mathematics we need a formal proof of things which are infinite. ठीक है? So we need a formal proof for that, which we are not going to do the proof. We are just going to use the statement only that every non-empty bounded above set must have supremum in R, and the same result can be framed for infimum property. Anyways, this result is related to supremum property, so this is also known as supremum property. Okay. और एक चीज़ और है, ऐसा नहीं है कि ये R में ही होता है, ये इसलिए भी इम्पॉर्टेंट रिजल्ट है बिकॉज इट इज़ नॉट ऑलवेज इन इट इज़ in R only. For example, if I take, if you have attended my initial lectures on real analysis, I have shown you all the algebraic properties of R, and then we did some order properties of R, and with this R becomes an ordered field. C, the set of complex numbers, it has all the algebraic properties, but we cannot define an order on C. So C is not an ordered field. With this property, R becomes a complete ordered field. Now Q, the set of rationals, which is a subset of R, that is a field. That is in fact an ordered field, but Q is not complete because I can show you that. For example, if I take this set X belongs to Q such that X is less than √2. This set, this is a non-empty set of rational numbers, and I have taken this set and I can prove that its supremum to be √2, which is an irrational, which does not belongs to the properties every non-empty bounded above set of rationals must have a supremum in Q. That we cannot say. That is why Q is not complete. It is an ordered field, but it is not complete. R is a complete ordered field. C is simply a field. Anyway, let's come back to our main topic, which is Archimedean property, and we are going to use this property in Archimedean property. Okay, so next is Archimedean property. Archimedean property. Okay, that property says that give me any real number, I will give you any real number, you can always find a natural number which is greater than that real number. Now it seems again obvious. If we see, look at the line, आप बोलोगे कि मैम I am giving you this number, this is the number greater than that, this number greater than that. Yes, it is possible, but as always in, see, real line is infinite, we don't know where it ends. तो आप कब तक ये करते रहोगे? So again we need a formal proof, as I have always told in my classes, that we need a form with things which seems obvious to us, but we need a formal proof to further, create some theory and everything. We need a formal proof. So the result is, the statement is कि if x belongs to R, then there exists n suffix s belongs to n such that nx is strictly greater than x. किसी भी रियल नंबर से बड़ा आपको एक नेचुरल नंबर मिलेगा. दैट इज द स्टेटमेंट. ओके, सो नाउ वी आर गोइंग टू गिव द फॉर्मल प्रूफ, मैथमेटिकल प्रूफ. नाउ व्हाट इज द प्रूफ? हम उल्टा मान लेते हैं. फॉर एग्जाम्पल, किसी चीज के लिए, हर रियल नंबर के लिए कोई चीज प्रूव करनी है, हर रियल नंबर के लिए उसके लिए कॉन्ट्रारी हम कॉन्ट्रडिक्शन से करेंगे. सो लेट इफ पॉसिबल, हम बोलते हैं ये चीज नहीं हो रही है. अगर ये चीज नहीं हो रही है, इसका मतलब उल्टा क्या हो रहा है कि सारे नेचुरल नंबर्स क्या हो गए, सारे के सारे नेचुरल नंबर x से छोटे हो गए. लेट इफ पॉसिबल n is less than equal to x for all n belongs to n. Now I have told you, you must know the upper bounds and everything. Now with this thing, my x, this x becomes an upper bound for n. Therefore x is an upper bound for my set, which is the set of natural numbers. Now it is upper bound. Now n is a, so now you can see that now n is a bounded above non-empty subset of R. Bounded above non-empty subset of R. That means now I can apply my completeness property to this n, right? So now by completeness property for R, n has a supremum in R. Obviously, maybe may not be in the natural number, but it has a supremum. N has a supremum. Say U belongs to R. ठीक है? Now U minus 1 is strictly less than U, right? U is the supremum of n and U minus 1 is strictly less than U. That gives me what? That gives me U minus 1 cannot be an upper bound for n. U minus 1 can't be an upper bound for n. Now what does that mean? If a number is an upper bound, means all the elements of that set is less than equal to n. Now if it is not an upper bound, इसका मतलब this implies there exists m belongs to n such that m must be greater than u minus 1. And this gives me m plus 1 is greater than u. Now m belongs to n. So we know that m plus 1 will also belongs to n. It is also a natural number. A natural number, how can be it greater than u? Because u is the upper bound. इस property से, with this property, we can say that u is not an upper bound. U is the supremum, so it has to be an upper bound. So we are getting a contradiction. So how we are going to write this? As m plus 1 belongs to n and m plus 1 is greater than u, therefore u can't be an upper bound is the contradiction because u is the sup n. A contradiction. A contradiction as u is equals to sup n. Sup n, supremum. Supremum means the least upper bound. It has to be an upper bound and it must be the least upper bound. जो सबसे छोटा upper bound होता है, that is my supremum. So I am getting a contradiction. इसका मतलब contradiction to what? इसका मतलब मैंने कुछ ऐसी चीज assume की है which is not true. और मैंने क्या assume किया था? मैंने बोला था कि natural number सारे के सारे x से छोटे हैं. तो इसका मतलब अब ऐसा नहीं है. कोई ना कोई नेचुरल नंबर तो ऐसा है जो कि मुझे x से बड़ा मिलेगा ही मिलेगा. So therefore there exists an x belongs to n such that n x is greater than x. Okay, anyway, so book I am following is the RG Bartle. ठीक है, दैट इज द एलिमेंट्स ऑफ रियल एनालिसिस बुक. उसी में से ही मैंने चीजें ली हैं या प्रॉब्लम्स अगर मैं आगे लेती हूँ तो उसी बुक में से लूंगी. तो उसी में ही आर्किमेडियन प्रॉपर्टी के बाद नाउ सम कॉरोलरीज और आई कैन से सम एप्लीकेशंस ऑफ आर्किमेडियन प्रॉपर्टी. द वेरी फर्स्ट एप्लीकेशन इज show that the very first application I can say to be just say result, okay, is show that infimum of this set 1 by n, n belongs to n is equals to 0. Now if you have attended my lectures on supremum and infimum, you must know what is सुप्रीमम व्हाट इज इन्फीमम. और इस सेट का हमने डिस्कस किया था, इसी पर्टिकुलर सेट का हमने डिस्कस किया था. सुप्रीमम इज 1. दैट वाज प्रीटी ऑब्वियस टू प्रूव. व्हाई? बिकॉज ऑल द एलिमेंट्स आर लेस देन इक्वल टू 1 एंड 1 बिलोंग्स टू द सेट. दैट इज व्हाई इट इज द सुप्रीमम. इट वाज अ सिंपल प्रूफ बिकॉज वी हैव डन दैट if a set contains one of its upper bounds or lower bounds, then that upper bound or lower bound respectively must be the supremum or the infimum. पॉइंट ये है कि यहाँ पर क्या हो रहा था कि जो इसका इन्फीमम है वी आर सेइंग दैट 0. तो 0 को वी आर एबल टू प्रूव दैट कि 0 इज द लोअर बाउंड, बट प्रिसाइसली इट इज द इन्फीमम. इट इज द ओनली ग्रेटेस्ट लोअर बाउंड. वो चीज हम नहीं उस वक्त कर पाए थे. तो दैट वी आर गोइंग टू डू इट बाय आर्किमेडियन प्रॉपर्टी, राइट. सो लेट्स स्टार्ट विद दिस. नाउ सी, ओके, लेट मी डू लाइक दिस. ओके, let infimum of this set to be w. Just to बार बार लिखना infimum इतना बड़ा है, we will just write it to be w and our target is to show w is equals to 0. ठीक है. Now first see, 1 by n is greater than equal to 0 for all n belongs to n. Therefore 0 is lower bound for n. Sorry, for that set. I'm sorry, for that set. For that set. Just a second. Okay, so for that set which is 1 by n, n belongs, so I can take that set to be S. Initially we can define it to be S, so that हम बार बार उसको इतना बड़ा सेट नहीं लिखेंगे. Okay, so 0 is the lower bound for this set. lower bound आ रहा है, इसका मतलब infimum और lower bound में क्या रिलेशन होगा? infimum is W and this is the lower bound. तो इन दोनों में क्या रिलेशन होगा? lower bound जो greatest lower bound होता है that is my infimum. तो इससे क्या आ गया? therefore W is greater than equal to 0. ठीक है. Now my target is to show that W is precisely 0 only. For that, let epsilon greater than 0 be any real number. Be any real number. Okay. Then 1 by epsilon is also positive. Now we are going to apply my Archimedean property to this number. ठीक है. Now by Archimedean property, I can just write to be AP property. Okay, Archimedean property AP. We can simply write this. ठीक है. There exist n in this such that n is greater than 1 by epsilon. This implies epsilon is greater than 1 by n. Now 0 is less than equal to w आया था हमारे पास. W क्योंकि वो आपका W इन्फीमम है तो वो आपका लोअर बाउंड भी हुआ, एंड 1 by n इज एन एलिमेंट ऑफ S, तो इट इज लेस देन इक्वल टू 1 by n, एंड 1 by n इज स्ट्रिक्टली लेस देन एप्सिलॉन. ठीक है, तो इससे हम इस वाले रिजल्ट पे आए, 0 इज लेस देन इक्वल टू W इज लेस देन एप्सिलॉन. ठीक है, 0 इज लेस देन इक्वल टू W इज लेस देन एप्सिलॉन. नाउ सी एप्सिलॉन वाज आर्बिट्रेरी. We have not given any condition. We said let epsilon greater than 0 be any real number. तो हमारे पास क्या आया? Therefore, basically, precisely less than equal to W is less than epsilon for all epsilon positive. Now again we have done this result if A is a positive real number such that 0 less than equal to A is less than epsilon for every epsilon means ऐसा number जो कि हर positive number से छोटा है, ऐसा number जो कि positive है and which is less than with every positive number, that is precisely 0. Again seems obvious but we have a formal proof for that which you can refer to my notes. So we have this common that gives me W is equals to 0. So we have used this result. This is from section 2.1 or 2.2 from Archimedent. You can check that. Okay, so that was my my target was to show W equals to 0 means infimum of this set 1 by n belongs to n is 0. So now using this condition that 1 by n का जो infimum है that is 0, इससे हम बहुत सारी अपनी problems कर सकते हैं analysis की. ठीक है, okay. So next है आपका हमारा है जो इसमें result है which precisely we are going to use in that density theorem. That result is if y positive then there exists ny in n such that ny minus 1 is less than equal to y is less than equal to ny. Obviously the one should be strict inequality but Bartle में इसी तरीके से दिया हुआ, तो that is why I am writing statement in that way only. So if I take any positive real number that must lies in the consecutive natural numbers. That again seems obvious but we need a formal proof for that. Okay. For this we are going to construct a set. Let EY is equals to m belongs to n such that m is greater than y. मैंने एक ऐसा सेट लिया है नेचुरल नंबर्स का जिसमें y से बड़े सारे नेचुरल नंबर्स मैंने उसमें लिए. ठीक है, देन EY is non-empty. How? By Archimedent property. Because that says that for every real number we must have a natural number which is greater than that. तो इसमें एटलीस्ट एक एलिमेंट तो मुझे मिलेगा ही मिलेगा ना, तो that means it is non-empty. So therefore EY is a non-empty set of n, natural numbers n. Okay, so now I don't know you're aware of this or not. Well ordering principle, that is the property of n. Well ordering principle, it says that every non-empty set of a natural number must have a least element. लीस्ट मिनिमल एलिमेंट, मैक्सिमल एलिमेंट, ये सारे जो कॉन्सेप्ट्स हैं ये आपके आई थिंक सेक्शन चैप्टर 1 बार्टल में मिल जाएंगे. सो लीस्ट एलिमेंट का मतलब वही है मिनिमम एलिमेंट, और वी से दैट लीस्ट एलिमेंट, पॉइंट ये होता है कि वो लीस्ट एलिमेंट आपका उस सेट में भी बिलोंग करता है. सो बाय वेल ऑर्डरिंग प्रिंसिपल, EY has a least element. Next, EY has a least element, say NY. ठीक है, कोई ना कोई लीस्ट एलिमेंट होगा तो मैंने उसका नाम कर दिया NY, which belongs to N. लीस्ट एलिमेंट है एन वाई है और वो आपका ई वाई में भी बिलोंग करता है, लीस्ट एलिमेंट का मीनिंग ही होता है, ठीक है। नाउ ई वाई एन वाई सॉरी बिलोंग्स टू ई वाई, इसका मीनिंग होता है देयरफॉर एन वाई इज ग्रेटर देन इक्वल टू वाई और स्ट्रिक्टली ग्रेटर देन, आई थिंक लेट्स सी दिस, यस m is greater than y, तो हमारे पास आ गया and y is strictly greater than y. Let me just erase this. Okay, so and y is strictly greater than y. Now it is the least element. इसका मतलब इससे छोटा जो natural number होगा वो e y में नहीं होएगा. Also n y does not belongs to, sorry, n y minus 1 does not belongs to e y. e y में होने का मतलब है सारे एलिमेंट्स y से बड़े हैं, ई वाई में ना होने का मतलब है कि एन वाई माइनस 1 लेस देन इक्वल टू वाई, ठीक है। नाउ यू कैन मार्क दिस एज 1 एंड मार्क दिस एज 2, फ्रॉम 1 and 2, फ्रॉम 1 and 2 we have this condition, n y minus 1 is less than equal to y is strictly less than n y. Right? Okay, so that was the consequences which are related to Archimedean property. Now we are going to do the density theorem. Okay, so density theorem we are going to use this property as well as some Archimedean property results. Okay, so let's just start with this density theorem. उसके बाद we will do some problems if time permits. Density theorem. What is that theorem? It says that if statement, if x, y are two real numbers such that x is less than y, कोई भी दो real numbers आपने लिए in this way, x is less than y, then there exists r belongs to q. r rational number होगा जो कि इन दोनों के बीच में मिलेगा. There exists such r such that x less than r is less than y. Maybe come across कहीं ना कहीं आपने सुना भी होगा या जो भी है. So between any two real numbers there always exists a rational number. कोई भी दो real number उठा लो, उनके बीच में एक rational तो आपको मिलेगा. By the way, एक से ज्यादा मिलते हैं जब एक मिलता है. तो anyways for the time being हमारे पास एक rational number होगा which lies between x and y. How we are going to do that? We are going to do it in two parts, taking on the conditions on x. Okay, case first. If x positive, ठीक है, then आपके पास आएगा if x positive. Let me just do it because I am not, इसमें हम थोड़ा सा बाटल को follow नहीं करते हैं. I do my own proof. Anyways, if x less than greater than 0, then see we have this condition 0 is less than x is less than y. ये तो हमें given ही है और x greater than 0 हमने assume कर लिया है. Okay, then y minus x is positive. This implies 1 upon में y minus x is also positive. Now I am going to apply my Archimedean property on this number 1 upon में y minus x, means मुझे एक natural number मिलेगा which is greater than 1 upon में y minus x. Okay, so by Archimedean property there exists n belongs to n such that n is greater than 1 upon में y minus x. Right? Now y minus x is positive. आप मल्टीप्लाई करोगे जो आपकी इनइक्वालिटी है वो प्रिजर्व रहेगी, वो चेंज नहीं होगी. सो ये होगा आपका ny minus nx is greater than 1. This implies ny is strictly greater than 1 plus nx. Mark this as 1. Okay. Now जो आपका जो अभी रिजल्ट किया था हमने कि आपने कोई भी पॉजिटिव नंबर लिया दैट ऑलवेज लाइज बिटवीन टू नेचुरल नंबर्स, तो वो आपके पास आएगा. नाउ सी आपका है x पॉजिटिव तो nx इज ऑल्सो पॉजिटिव. देयरफॉर देयर एग्जिस्ट m बिलोंग्स टू n सच दैट m minus 1 is less than equal to nx is strictly less than m. Precisely हमारे पास यही रिजल्ट आया था. Okay, now see this, nx here is less than m right? Nx is less than m, and if you see this m here is less than equal to nx plus 1. यहाँ से अगर आप देखोगे तो m is less than equal to nx plus 1. Now from 1 and 2, from 1 and 2, see this, from 1 and 2, from 2, nx is less than m, nx is less than m is less than equal to nx plus 1, and further nx plus 1 is less than ny. तो हमारे पास दोनों से कंबाइन होके ये रिजल्ट आएगा ny. This implies x is less than m by n, which is less than y. Now you can see that m and n are natural numbers. M by n should be a rational number. So therefore there exists r equals to m by n belongs to q such that x is less than r is less than y. That was what we have to prove. But we have to see x could be any real number. So we have considered the case when x is greater than 0. Now we will do when x is less than equal to 0. So case 2, if x is less than equal to 0, then we can choose k which is greater than minus x. This can be done by using Archimedean property. We know that we can find any integer greater than any real number. So minus x से बड़ा भी आपको एक positive integer और a natural number आपको मिलेगा ही मिलेगा. That then k plus x is greater than 0. So therefore 0 is less than k plus x. Now x is less than y, so k plus x is less than k plus y, which is less than k plus y. Now see, we have these two numbers k plus x and k plus y, and these are positive numbers. तो जैसे हमने case 1 में किया है कि positive numbers के लिए you get a rational number between two real numbers, तो यहाँ पर k plus x and k plus y के लिए आपको एक rational number मिलेगा. So we can say that by proceeding as in by proceeding as in case 1, there exists r belongs to q such that k plus x is less than r is less than k plus y, right? Now see, this implies x is less than r minus k is less than y. Now r is a rational number, q basically is a rational number, it's simply an integer. R minus q would again be a rational number, as r minus k belongs to q, ठीक है? Hence the result is done, or you can simply say it is proved. So that was the density theorem. Now density theorem says that between any two real numbers we have a rational number. Next we are going to do a corollary which says that, which we are going to use this density theorem, but that corollary says that between any two real numbers we can also find an irrational also. Okay, so that is why we have infinite rationals and infinite irrationals, because we have infinite real numbers. Anyways, so corollary, if x, y are two real numbers such that x is less than y, then there exists an irrational. We don't have basically a standard notation for irrational numbers. We have for r, we have for n, we have for q, but irrational sometimes I we can write, but not the standard one. So there exists an irrational number, say z, such that x is less than z is less than y. ठीक है, दो लाइनों का प्रूफ है ये, because we are going to use the density theorem. Now see this, x is less than y given है. This implies x by root 2 is less than y by root 2. Why? Because root 2 is a positive number. 1 by root 2 से आप multiply करोगे, doesn't impact the inequality. Anyways, now these two are real numbers. By density theorem by density theorem, there exists say R belongs to Q such that x by root 2 is less than R is less than y by root 2. Okay, this implies x is less than R root 2 is less than y. Now you have obviously done in your 10th standard, I guess you must have done that R root 2 is an irrational number. R is a rational number, root 2 is an irrational number, then R root 2 would be an irrational number. Proof करना बहुत simple है. Assume it to be P by Q. Doing this you will be able to prove that root 2 is rational, which is a contradiction. So this is rational. Therefore there exists Z equals to R root 2, an irrational number such that x is z is less than y. ठीक है? Now next few problems which you can do with that set infimum of 1 by n is 0. We time is very less, so what we can do is मैं एक छोटा सा आपको आइडिया दे देती हूँ. अगर आपको एक सेट दिया है 1 by n minus 1 by m such that nm belongs to n. अब आपको इसका सुप्रीमम फाइंड आउट करने के लिए बोला जाए तो आप क्या करोगे? टेक दिस, लेट a टू बी 1 by n and b to be 1 by m, where m belongs to n. Then sup a is equals to 1 is equals to sup b. ठीक है? And inf a, now we can do the infimum. तो inf a is equals to 0 is equals to inf b. Now see this, s is nothing but your a minus b, and now if you know these results, supremum of s is sup a minus b. This will turn out to be sup a minus है क्योंकि इसलिए हो जाएगा inf b. So now you can see that it is 1 minus 0, which is 1. In a similar way, you can calculate infimum of s, which would be inf a minus sup b. So it will turn out to be minus 1. So in this, इस तरह की जितनी भी problems है, you can easily do, right? Okay, so I think we have to stop here only. So we will be continuing in the next lecture, hopefully. Okay, thank you.